Hello students. Next let us look into the last topic of first module. Even though it's the last topic, there are a lot of subtopics in it. So I will try to complete it within 2 or 3 parts. Okay. So first is the topic is robots in industry. So generally this should have been taken by the end of the third module or by the end of the course itself, because many terminologies that are used here will be understandable much better only after you have gone through the complete subject. But it does not matter anyway, because at the end of the course, once you revise it, you will again go through the same portions and you will understand it much better when you read them. Okay, anyway, let us talk about robots that are being used in industry. There are many areas where robots are being used in industry. Okay, basically a robot is a reprogrammable, multifunctional machine which is designed for what? It is designed for manipulating materials, parts, tools, or specialized devices with the help of programming. And why is it basically programmed? It is programmed to use these materials, parts, tools to do or carry out various tasks or perform various tasks on these tools and materials. Because of this, it is very much used in industrial tasks, and today 90% of all robots are referred to as industrial robots. Why? Because they are mostly being used in industry. Most of the robots are mostly being used in industry nowadays. That's why we generally don't see them around unless and until you visit some factory or you see some video of some factory. I can give you some very good examples, some of which, for example, car industry. Nowadays, most of the car industries are heavily using robots. Amazon, for sorting out the packages, is actually using robots for sorting purpose. Heavy robots are used in heavy industries. Even there are robotics being used for handling nuclear fuel in nuclear power plants. So like that, 90% of the robots that are being used in factories are known as industrial robots. So 90% of all robots that we use are mostly found in factories. Now they are slowly finding their way into warehouses and laboratories. Laboratories, for example, take the case of COVID situation. Right now, in other countries, there are robots which are being used in laboratories to test the samples so that no contamination takes place. Okay, and even research and exploration sites are using it. For example, if you want to go for a deep sea diving, nowadays robots are being used for deep sea diving and exploration, or to those places where human access is not possible, unmanned vehicles are going. Okay, similarly power plants, hospitals, and even outer space. I will send you some of the robotic activities undertaken by NASA for basically previously and all. If they wanted to repair something in space, they used to use, they had spacewalk. So an astronaut will put a dress and he will walk out in space and repair. But nowadays they are having a robot which is connected directly to the vehicle, and directly with the help of vehicle they are doing the repair work in outer space. Or even take the case of robotics being used for Mars exploration. We all know about the various robots that have been dropped, or even our Chandrayaan was supposed to be a robotic mission. It had a small rover. So like that, robots is now finding its way into many other places where human access is not possible or it's dangerous. Okay, now what are the basic advantages why it is used in industry is, you can look at these advantages, that robots can be operated 24 hours, can work 24 hours a day, 7 days a week. No need to switch it off. It can just keep on working, keep on working, keep on working. Humans, they can work only in shifts, and that also for a considerable amount of time only, not for too long. Okay. Similarly, when the task is dangerous, okay, when the task is dangerous for a person, robots can do the work. That is another, for example, suppose you want to have mine, that means you want to find out the mines they are located in war field. If mines have to be, taken out from the ground, previously humans used to do it, and that was always a risk. There was always a risk involved. Whereas now that is not the case. Now that is not the case. Now we are having basically robots do that work. Similarly, in case of mining, if too much they have to go to too much depth, nowadays they are having robots do that. Or even diving, undersea diving at great depths is a huge risk for humans, and there is always a huge risk of death for those divers, whereas nowadays we are having robots do that job. So whenever there is a task that is dangerous, robots can do the work. That is another reason why robots are chosen. Similarly, robots do not get bored. That means once you install a robot, you need not go and there is nothing called as a resignation from a robot, or that that he is bored out of it. So any repetitive work which may be a very boring for one person might not be in any way boring for a robot. The robot can keep on doing the same work again and again. So these are some of the advantages why robots are preferred in industry. Now if you are going to look at industrial applications, okay, in your syllabus you will find that many industrial applications have been listed. Okay, many industrial applications have been listed, and we will deal with them one by one. Okay, now what are the various industrial applications? You can see here there are various applications. For example, material transfer. That means you want to take one material and transfer it somewhere in the factory floor somewhere else. Okay, or you can have machine loading. That also can be handled by robots. Spot welding. Previously, welders used to be in great demand, but nowadays they are having spot welding directly within the factory. So no need of human beings doing that job. They can do some other important job, and the robot can handle spot welding. Similarly, if there is continuous arc welding also, it can be handled by robots. Spray coating, one of the hazardous climate for humans to work. Spray painting or spray coating, today most of the companies are having robots do the task. Next is material removal. That means if you want to use pressurized water or steam to remove material, or if you want to use a lathe machine to remove material, for all these robots can be used. Cutting operations, for cutting metals, for cutting wood, for cutting other materials, we can use robots. Similarly, assembling operations. Assembling operations means, for example, you want to assemble a car. So you might have seen there is a floor, there is an assembly floor, and the crane and the car basically starts as a frame, and one by one the parts are assembled into the frame, and finally at the end of the factory line a car will come out. So assembling operations also we are having robots. Similarly, if we want to inspect parts, or even for the case of food items, for example, if suppose there is a factory which manufactures, for example, you take Lay's factory, potato chips. The factory basically has in the end a robot which looks at the shape of the Lay's chip and basically uses blow air to blow away chips that are not the required size or required shape. So that kind of sorting operation, that kind of part selection, part inspection is being done by the robots nowadays. Okay. Similarly, part sorting to find out which part is what. Then part cleaning is done by robots. Polishing of it, that is also done by, and a dozen more specialized tasks. All these are being done by the industrial robots. And these are tasks that we are going to discuss in detail below. First, let us talk about material handling. Okay, whenever we visit any factory, you will find that most of the time heavy machinery is being transferred from one place to another, and about 95% of time that is spent in basically transferring and waiting for the material to reach, and only about 5% is utilized for actual work. That used to be the case previously. Now with the help of robots, they are trying to reduce this time involved in manufacturing, basically by reducing the time that is involved for transfer and wait, because for transferring they are using robots. So it's like assembly line. There is this concept of assembly line wherein the material is transferred from one point to another and work is going on in between or at a particular station, and then the assembly line moves forward. Okay, for example, loading and unloading machines are the major applications of robots. So for loading the machine, for unloading it, okay, for uncoupling it, we require robots. There are basically two basic configuration: robot tending a single machine and robot serving several machines together. Okay, so there might be a robot which is just operating on one equipment at a time or one material at a time, or there may be a collection of material and there is one robot which is taking care of each of these. Okay, that is the two basic configurations that we are having in material handling. Now the material that is being handled, it may be very heavy or it may be light. Based on that, we will use different kinds of robots with actuators that are powered either by pneumatic or electric method. Let me write that. See, the robot is powered, or actuators are used to power the robot. Okay, the actuators may be pneumatic, that means instead of hydraulics, hydraulic means wherein you use the hydraulic pressure to generate power. Similarly, pneumatic, we use the air pressure. Okay, or sometimes it may be electric. See, when you will study in the next module, you will understand what is the difference and what are the characteristics. And one of the characteristics is that there is huge amount of pressure or power that can be generated using hydraulic actuators. So hydraulic actuators are used for heavy machineries, whereas electric actuators, they cannot lift very heavy load, but they are very fast and very efficient and very clean. Okay, so these two are used for heavy, out of which hydraulic is used for really heavy. Okay, so the type of robot will depend based on the material, the weight of the material. Okay, so non-servo means non-electric. Non-servo controlled pneumatic robots can be used for it. For medium-sized electrical types, we can use small materials, or we can have even huge, massive hydraulic manipulators that use hydraulic for their actuators. Now when we are talking about material handling application, what is necessary is a point-to-point configuration of, we saw continuous path, isn't it? We know the three configurations, we have already studied it previously. If you remember, I will take you there. So point to point was there, continuous path was there, isn't it? So point to point configuration or control system is necessary for robots that are used for material handling. Why? Because it has to be taken, the material has to be taken from one station to another. So point to point control robot is required. Okay, the controller should be able to store large number of points and have facility to easily program horizontal and vertical increments. Okay, next application is welding. What is welding? Welding is basically you heat two metals. So if you want to join two metals together, you apply heat. Okay, you apply heat, and once you apply heat, the two will melt and they will join together. Okay, that is what is written here when we say the welding operation performed by robot are thermal process in which the metals are joined by melting or fusing their contacting surface. There are two kinds of welding that will take place. One is where there is no filler material. Okay, that means you just take two materials and you heat them to a point that they melt and then you fuse them. The second type is when you use a filler material. For welding two materials, you use a filler material and you don't heat the two objects very much, but you heat the filler material and then basically you are using it to join. For example, for the case of soldering, for the case of soldering, there is a copper underneath, okay, and from the hole you are having the pin of the component coming out. And what do? We basically apply a filler material like solder to solder the pin to the copper surface. Okay, so we apply, that is called as soldering in electronics. So solder is where you basically use a filler material. So just like that in welding also, we are using heat to basically melt the parent material, and that is placed here in between two materials, and then this is pressed on top of it so that both of them fuse. Based on that, we are having two types of welding operations. One is called as spot welding. Wherein the spot welding basically belongs to the first category, wherein we are basically joining the interface of two materials by just heating, melting them and then pressing them to each other. We don't use a filler material. Okay, so the spot welding falls in the first category, and only at certain points we join the metal. Okay, so we generate the required heat, and once there is enough heat, the metal starts to melt, and then we press them by joining the two ends together. We press them, and that's how spot welding is done. And spot welding is basically used in automotive industry. Suppose you are having one plate like this, and you have to attach it to another plate which is below it. Okay, now see, I have shown the cross section of the plates. Okay, now what we do is we apply heat on both sides and pressure also. Okay, so these are the heating rods and the pressure rods. So current is passing through them. Because of the current flow, these material at this point they melt, and then finally with the applied pressure they both of them fuse and join. That is called as spot welding. Where the metals are joined. Okay, there is no filler material. Next is arc welding. Arc welding is where you are having the second case, wherein there is a requirement of the filler material. So what will you see? You have seen arc welding where a person is having a small face mask in front of him, and he is basically using a arc welding machine, and the machine is basically having a tip, a material, there is a rod, and that rod and the material where you want to do the work that material is basically kept as grounded. It is kept grounded means the current should flow through it. And what happens is that current is passed through this material and it is kept very close to the surface. When you keep very close to the surface, since this might be metal, it's also conducting, there is an arc developed there. What is the meaning of arc? Arc is when you have two metals which are at different potential. Suppose this is at highly positive potential and this is at a highly negative potential, then between them there will be spark. And that spark, if the potential is too high, the spark can keep on remaining for a long duration of time, and that will basically produce lot of heat around this. So just like that, the tip of the welding rod and the material, they are just brought so close to each other that there is spark in between, and that spark is used for generating heat that will melt this material, the rod, because that will have a lower melting point. So that will first melt, and that melting material is used to join any two materials together. Whatever you want to join here with another material, that you can join. Okay, so arc welding falls in the second category, in which the two metals are joined along a continuous path. So it is not spot by spot, but it is basically continuous path. The required heat is provided by an electric arc generated between the electrode and the metal. So this is the electrode, and this is the metal. And when you bring them close enough, you generate what is called as arc that I have drawn here. Okay, so that happens when the two materials are brought very close to each other. So actually, when you see people welding, people always think that this is being touched on the metal. No, if you touch on the metal, the two metals come to contact. The two metals, if they come to contact, then the current will directly flow, and there is going to be no arc. If there is no arc, there is no heat. So in welding, the material should not be touched by the rod. There has to be a very small distance, and then you try to basically move it. Okay, so that is what is arc welding. Okay, next we will look at spray painting. Spray painting is very important for robot work because spray painting is one of the hazardous job. Okay, the spray painting is one of the most unhealthy and toxic environment. It's very unpleasant to remain in a place where painting job is actually taking place. It's very difficult. Why? Because the solvent material that is being used for spray painting is very toxic. That is one of the reasons. The smell is very toxic. You will feel as if you are having a headache. You have a nauseating feeling. Another thing is that the painting area generally should not have any dust. Why? Because the finishing of the material will be affected if there is dust in the environment. What will happen? The finishing of the paint, it will have these dust particles stick onto it, which will not give a very good appearance. So the environment should be dust free. And also for the paint to dry, the temperature should be very much controlled. It should not be cold. It should not have certain humidity. There should be a certain high temperature. Then only the paint will stick onto the surface as it is required. Similarly, there is a lot of noise that is there when we are using spray painting because of the nozzles. Okay, so the noise that is there because of the compressor that is used for spray painting and everything, it is very, very loud, and it can be very damaging for the ear. So because of these things, the very first application of robots came in the field of painting. Okay, and the requirements of the robot will vary from one painting job to another. Okay, for example, As an example, we have shown that a spray painting generally they should have this continuous path and not point to point capability. They should have this continuous path capability, and they should have many things like high level of manipulator dexterity. That means the robot should be very fast, and it should be able to move very fast and very smooth. Okay, then it should have a large working volume, compact wrists. It's wrist. The spelling is wrong. WRIST. You should have a very compact wrist. Then the payload should be very small. Payload should be very small in the sense that since the length of the robot should be large, it cannot carry very heavy load. So the paint should be at the base, and the robot arm should only have a very small payload. Okay. Similarly, the accuracy is not that much required because painting job does not require the point to point job like welding. In welding, there it has to be the exact point. Whereas painting, spray painting, it is basically for an area, so the accuracy and repeatability is not that much a bigger requirement. So, like that, for each and every case, based on the material handling requirement, the specification of the robot will change. Okay, that is what is written here. Written here that the requirement for repeatability and resolution are the least for painting jobs or painting robots. Okay, so that is what is we have about painting robots. I will put a small video of all of this to basically give you a small understanding. At the end of the chapter, I will give you certain videos of these robots. Okay, next we'll have to look for assembly. That I will do in the next part.